I'm a manufacturing engineer at Mancor Industries, the steel manufacturer in Oakville, Ontario. Today, I'd like to talk to you about our process, continuous improvement process, or what's called process walk. So it started, it's a routine process at Mancor to improve poorly performing processes of parts. Provide quick focus improvement. We engage all staff in different departments, teach others what the process we do duplicated, and we try to achieve at least 50% improvement in whatever area we're working on. I'll take you through the steps and I'll provide an example that we did this year. So we pick a part, and usually parts that have issues in quality or cost or throughput or inefficiencies. And then we pick the team, and the most important thing is it's a multidisciplinary team, so we get a representative from production, engineering, quality, management. And then we sit together, we set our goals. And goals are really important too, so you're not kind of all over the place. We set concrete goals in terms of production, productivity, improvement in time reduction, and safety, and things like that. So we consider all areas. Then after that, we do the videotape process. So before this year, we used to do a process walkthrough, which was we'd physically go in the shop and follow the part as it's going through all the different processes. And then that took a long time, and you couldn't remember what we need to improve on. So what we did this year was we did a videotape. We made a video of the process. Anyone can do this. In our case, the engineering students who work for us did that. And then we come together and review the video, so we can play on a big screen, watch and fast forward, so we're not wasting time. We can skip, we can replay, or rewind and look at parts as needed. Ask why, pause, get feedback from people, and then brainstorm improvements as we see the waste in the video, and we can follow our goals after that. So, and then after that we pick the improvements, we kind of document it and put numbers to it, and then implement the improvements, so we get working on it right away, and then we do follow-up meetings, and kind of quantify our results and compare them to the initial process. So now I'm going to do the example of this part, which is a winch mount. Now this part is about 4 to 5 feet long, a couple hundred pounds, just so you get a picture of it. So we want to take 50% out, that was the goal, take 50% out of the tacking, welding, processing time, improve the capability, eliminate the quality issues. We had some quality issues with this part regarding everything from weld quality to parallelism, perpendicularity, all that stuff. We picked a part that's kind of a decent quantity for EAU, 250 per year. So our team is here. Somebody from welding, that's me second, and the robot programmer, and somebody from QA and robot operators. So we got operators, managers, and engineering involved in this. So the results, what we found, I won't go through all this, but when we detailed where the time wastage is, and all this stuff, we were able to cut in the stacking stage, putting the different components in the tack fixture and tacking it initially. We were able to save 9 minutes. And here are the details, -2 minutes here, 4 minutes there. When you tally it all up, it's -9. Next, the robot, this part gets robotically welded. So the pre-robot stage, that's where we do some pre-welding and things like that. We're able to cut 2 minutes. The reason being is we ended up adding 10 minutes. So we cut and add processes as needed. It's not only cutting, but overall it's cutting 2 minutes. The post-robot, so the robot welding time was pretty much the same. Actually, no, we had the post-robotic manual welding. We cut around, that's 25% of the total time. So that's the most cutting that we achieve in the whole process. We're basically able to eliminate a lot of manual welding that was done afterhand and putting it on the robot. And we did this through changing fixtures and orientation inside the robot and things like that, which came about from discussions and watching the video over and over. And here, this is the robot welding. So we increased the time of the part being on the robot, which is a good thing, because that's where you save time and money in the process. So these are our results. So the current was like the old method. Total time you see here, 176 minutes. The plan was our goals. Our goal was to do it in 126 minutes. In actual, what we ended up achieving is we did 110 minutes. So we beat our goals. And then we, did the video process again and went over it just to make sure that's how we got the times. And then, so we were able to save 66 minutes, 38% reduction. And that translates in a lot of dollar amount savings in the whole year. So these are the results. The good thing about this process too is that it's very quick. So we're able to turn everything around in a matter of 3 days. Just do, video, discussion, implementation, and we were able to even change the work area and the position of the welders, and just to kind of cut down the travel time of the part, or handling of the part. We increased the robotic welding, which improves the weld quality. We were able to even eliminate gaps and stuff in the parts. So when parts come together, we're able to change the part within the tolerance, just to eliminate gaps because they were causing part to deform and things like that when welding.